So we're going to start simplifying rational expressions, and these are the steps that you need to know. A rational expression is just a number that can be written as a fraction. And so basically these are the steps of simplifying big fractions. And you do need to know how you go about simplifying, and you do need to know how to factor. And if you can factor, simplifying rational expressions is super easy, but that will be the first step. And so you do need to remember that your steps to factoring include putting it in the correct order, looking for a greatest common factor, and then making sure you either do the A times C method or difference of squares depending on what you're looking at. The step number 2 is very important, and you notice I underlined factor twice. All you're going to do is cancel any common factor, and it has to be a factor that appears in both the numerator and denominator. So this is just simplifying fractions, and so here's just a fraction that you're normally used to seeing, and you may say to simplify this that you would divide by 2, and of course that's correct. And so 4/10 simplifies to 2/5, but I would like you to think about it in a specific way, and if you can do it this way, if you can think about it this way, it's going to be a pretty simple process. If you start off by going through the steps that I just described, you could use a factor tree, but let's rewrite 4/10 as its prime factors. And so that would mean that 4 is the same as 2 times 2, and 10 is the same as 2 times 5. And then everyone knows that the idea of anything divided by itself is just 1, and so what we can do is just cancel any common factors, and we still get to the 2/5. And so basically this is what you're doing when you are simplifying. You say divide by 2, but really you're just canceling out a factor that appears both in the numerator and denominator. So I'm going to apply the same idea to this one, and you've seen this problem before, and you still may think of it the same way, but just to stress the point that I'm trying to make here, let's rewrite this as its factors. And so then 18 can be 2 times 3 times 3, and t cubed is really t times t times t. And then I'm going to rewrite the denominator in the same way. 27 is really 3 times 3 times 3, and then of course there's 7 t's. So now all we're doing is canceling common factors wherever you see one. So these 3's can cancel as well as these, and then we can cancel 3 t's in each. And so what you would be left with is 2 over 3 times, and there's 4 t's, so t to the 4th. Okay, and you may, maybe use your exponent rules in combination with, divide both 18 and 27 by 9. This is the same thing, but this, if you understand this, it'll help you in the newer stuff. So the very first step when you're doing anything with simplifying rational expressions should be to factor everything you can. So you do need to remember how to factor. And, I went through the steps earlier. So here's an example problem of factoring, just to refresh your memory. There is no greatest common factor in here, and you should check that first every time. But we're going to say that A is 2, B is -3, and C is -2. And then the A times C method says we do 2 times -2, and that gives you -4. And then we need to think of all the factors of -4 that we can, looking for the ones that add to give us B, in this case -3. So outside of 2 and -2, the only other options would be 1 and -3. No, sorry. How about 1 and -4? Or -1 and +4. We need 1 and -4 because we're trying to add to get -3. So we're going to use that to rewrite it as 2x squared plus x minus 4x minus 2. And then we're going to group the first two and the last two together. Take out an x over here. We're left with 2x plus 1. And take out a negative 2 on this side and be left with 2x plus 1. And finally, that factors into 2x plus 1 and x minus 2. So again, the only real things that we're doing here is factoring everything we see and then canceling common factors. And so here's a little bit harder of a problem. We have 15 over 25a minus 30. And I'm going to work through all the steps that I would like you to think about. So 15 is really 3 times 5. And then in the denominator, we can take out a greatest common factor of 5. And we're left with 5a minus 6. Now we're looking for common factors. We have a 5 in each, and there's no other common factors. So our final simplified version of this is 3 over 5a minus 6. All right, I got 2 more examples for you. And again, the very first thing you should do is try to factor everything you can. Hopefully you recognize the numerator as a difference of squares. And that is going to be pretty easy then. So the square root of t squared is t. The square root of 9 is 3. And so one of them is t plus 3 and the other is t minus 3. In the denominator, we can take out a greatest common factor, and we're left with t plus 3. And then all we're doing is looking for common factors. T plus 3 is showing up in both numerator and denominator, so we can cancel them out. Again, that's just that they divide out to be 1. So the final simplified form of this is t minus 3 over 5. So for the final example, I'm going to use this. And the first step is to simplify everything you can. So the numerator, you can use a times c. There is no greatest common factor up there. So 1 times negative 4 is negative 4. Factors of negative 4 that add to give you negative 3 or negative 4 and 1. So then we can say x squared minus 4x plus 1x minus 4. And take out an x here, and we're left with x minus 4. Take out a 1 here, and we're left with x minus 4. And then it finally factors into x minus 4 and x plus 1. In the denominator, all we can do is take out a greatest common factor. So I'll take out a 4, and we're left with x minus 4. And now we're only canceling factors that have in common. And again, make sure they are factors. Don't cancel anything else. So then the x minus 4s can divide out to be 1. And that makes the final simplified version of this x plus 1 over 4.